Have you ever wondered why, a trip to the Amazon looks completely different from a hike up a snowy mountain? Or why some places are just absolutely bursting with life while others seem almost empty? Well, it is definitely not random. Today, we're going to take a quick trip around the globe to see how climate is basically the master architect, shaping all the incredible life we see on Earth. So, let's dive in.
So, this is the big question, isn't it? Why are these places so different? What forces are at play that create this lush green forest on one side of a mountain range and then a dry, almost desert-like landscape right on the other side? The answer, it turns out, lies in one single, really powerful concept that helps us make sense of our entire living planet. And that powerful concept is the biome. You can think of biomes as the fundamental building blocks, the major neighborhoods that make up our living world.
Okay, so what is a biome exactly? Well, it's a huge community of plants and animals that are all adapted to a similar environment. And the key to understanding them really comes down to two types of factors. First, you've got the abiotic. That's the non-living stuff, the climate, the amount of rain, the temperature, even the soil. And then you have the biotic, the living stuff, all the plants and animals that have figured out how to thrive under those exact conditions. It's this incredible dance between the living and the non-living that creates every single ecosystem we see. But that kind of raises another question, right? If biomes are shaped by climate, what shapes the climate itself? Let's dig into that connection and see how the physical geography of our planet literally creates our weather patterns. And this is just a perfect example, the rain shadow effect. Just picture it. You've got this moist air rolling in from the ocean, it slams into a mountain range and has nowhere to go but up. As it rises, it gets colder, and all that moisture condenses and just dumps down as rain. This creates a super wet, lush environment. But by the time that air makes it over the peak and starts to come down the other side, it's completely dry. As it sinks, it warms up, creating a much, much drier biome. So that one mountain range creates two totally different worlds sitting right next to each other. Now, to help us compare these different worlds, scientists have this fantastic tool called a climate diagram. It looks simple, but it tells you a huge story at a glance. That red line, that tracks the average monthly temperature, and the blue bars show you how much rain or snow falls on average. This little graph is basically going to be our passport for the rest of this journey. All right, passport stamped, our world tour begins. And our first stop is right near the equator, in the biome that is home to more species than all the other biomes on Earth combined, the tropical rainforest. Now, take a look at this climate diagram from Brazil. See that red temperature line? It's almost perfectly flat, and it is hot all year long. And the blue bars for rain? They're just enormous. I mean, we're talking at least 2 meters. That's over 6 feet of rain every single year. This constant heat and this constant water creates a really specific set of challenges for anything trying to live there. Now, here's a surprise. With all that life and decay, you would think the soil here is incredibly rich and fertile. But it's not. The nutrients get sucked back up into living things so fast that the soil itself is left pretty poor. That's why these giant trees grow massive buttress roots just to stay stable in the shallow ground. And with everyone fighting for a tiny bit of sunlight in the canopy, animals have evolved incredible camouflage and amazing ways to climb, jump, and fly through all those dense branches. Okay, so we've seen a world of abundance. Now, let's jump to the complete opposite ends of the spectrum. Places where survival is a daily battle. We're going from the scorching desert to the frozen tundra. And wow, this slide just says it all, doesn't it? On the left, you've got the rainforest we just saw, completely drenched in rain. And on the right, the desert. I mean, look at those blue precipitation bars. They barely even show up. This is a world defined not by too much water, but by an almost total lack of it. So every single adaptation here is about one of two things: saving water and beating the heat. Plants like cacti have basically become living water barrels. Tons of animals are nocturnal, so they only come out in the cool of the night. And some, like jackrabbits, have developed these huge ears, not just for hearing, but to act like giant radiators, shedding their excess body heat right into the air. So clever. All right, let's hop over to our next biome, the temperate forest. Now, looking at the climate for a place like Philadelphia, you see a totally new kind of challenge. That red line shows this big, distinct wave: cold winters and warm, wet summers. The defining feature here isn't just heat or just cold, it's change. It's all about the seasons. And to cope with that change, life has evolved two main strategies: You've got deciduous trees, which brilliantly drop all their leaves and just go dormant to save energy through the winter. And for animals, it's pretty much a choice. You either hibernate and sleep through the cold, or you migrate and get out of town for a while. Every living thing here has a plan for winter. For our final stop, we are heading way, way up north to Barrow, Alaska, and the tundra biome. And just look at this climate diagram. That red temperature line is below freezing for most of the year. The winters are long and just brutal, and the summer is incredibly short and cool. Here, the number one challenge is simple. It's the constant, unending cold. And the single biggest non-living factor that defines this whole biome is something called permafrost. This is a layer of soil just under the surface that is frozen solid all year round. And that is a total game changer because it means that big tree roots just can't dig into the ground, which is why the whole landscape is basically treeless. Survival here is really an art form. The plants grow super low to the ground, just hugging it to escape those constant damaging winds. And the animals that stick around all year are absolute masters of warmth. We're talking natural antifreeze in their blood, tiny little ears and tails to minimize heat loss, and of course, super thick layers of fat and fur for insulation. So we've gone to the wettest, the driest, the most seasonal, and the coldest places on Earth. Now, let's pull the camera back and see how all these pieces fit together into our planet's great patchwork quilt. And this map just shows it all so clearly. You can see those bands of tropical rainforests right around the equator, the deserts where dry air falls, the temperate forests in the middle latitudes, and the tundra sitting right on top of the planet. It's not random at all. It's a beautiful, predictable pattern, a global quilt stitched together by the threads of climate. So if you remember one thing from all of this, let it be this simple rule. Climate defines the challenges, whether that's a lack of water, brutal cold, or nutrient-poor soil. And life, in all of its incredible ingenuity, provides the solutions. Which leaves us with one last, very important question to think about. We've seen that climate is the primary architect of life as we know it. So if climate truly does define life, what happens when climates change?